Hello and welcome to this lesson on algebra. I'm Miss Mohamed and I'll be your teacher today. I'm a teacher of mathematics here in Manchester. I teach study skills, growth mindsets, and mathematical concepts. I focus more on problem solving and reasoning questions that are specifically GCSE questions. Today we are covering algebraic expressions, algebraic notation, substitution, formulae, expanding and factorizing, equations, identity, linear and nonlinear sequences. Most of them are on the foundation and higher curriculum, except for linear and non-linear sequences that is specifically for the higher curriculum. The first topic that we'll be looking at is algebraic expressions. A term is a number, a letter, or a number and a letter multiplied together. Like terms contain the same letter to the same power. You can simplify an expression by collecting the like terms. So if we were to look at this example, 3x and 7x, we have the same letter, x and x, and we have to the same power, x to the power of 1, x to the power of 1. So we consider these two as like terms. We do not consider these as like terms because, first of all, x and y are two different letters. And secondly, x and x squared have different powers. This is x to the power of 1, and this is x squared. If we were to simplify these expressions by collecting like terms, so if you were given this question and you're asked to simplify, this is what you do. So you add the like terms, 2a plus a, that gives you 3a, and then 3 plus 4, that gives you 7. You can also do the same when it's different powers. So in this case, you have 2x squared plus 7x squared, and x squared, we consider them as like terms because the same letter to the same power, 2x squared plus 7x squared, that's 9x squared, minus 2x plus 4x is plus 2x. Sam and Ben simplify 4a plus 7b minus a. Who is correct? Sam's answer is 5a plus 7b. Ben's answer is 3a plus 7b. What mistake did the other student make? So as you can see, instead of doing 4a minus a, Sam's answer was, he added instead of subtracting the minus a. So it should be 3a plus 7b, but he wrote down as 5a plus 7b, which is something that a lot of students make mistakes on. Terms can be simplified when multiplying or dividing, even when they're not like terms. A times b can be written down as ab. X divided by y can be written down as x over y. When multiplying, you write the letters in alphabetical order, and then you write the numbers before the letters. If we were to simplify these expressions, so if you were told 6 times y, you can write it down as 6y. 5 times 2p, it's 10p. The number comes first before the letter. C times b can be written down as bc because letters are supposed to be in alphabetical order. And then t divided by 5 can be written as t over 5. I want you to attempt to answer these questions, the exam style questions. Even though they're 1 mark or 2 marks, do not underestimate the value of it. So if you look at it, it's actually 4 marks for this question. And I want you to solve the questions on this one. So each bag holds n sweets. Write an expression for the number of sweets in 2 bags, 4 bags, 10 bags, and x. Okay, algebraic notation. To multiply powers of the same letter, you add the indices. So in this case, it will be 2 to the power of 6. X squared times x to the power of 4 is x to the power of 6. And this will be x to the power, y to the power of 11. Remember, it's the same letter. You add the indices. Same letter, you add the indices. If you can't remember this rule, just write it all out. So for instance, if we use this example, we can write it down as x times x, which is x squared, and then times x to the power of 4. So 1, 2, 3, and 4. That gives us x to the power of 6. And we know then that you had to just add the indices. To divide powers of the same letter, you subtract the indices. So remember, same letter, subtract. So in this case, it will be 6 minus 2. So that will give us a to the power of 4. This will be z to the power of 4. This is the same as well. If you can't remember the rule, please don't worry. You could just write it all out. So x to the power of 4 can be written down as that over x. So if you cancel these two out, you end up with x to the power of 3. Yeah? And this will be g to the power of 5. Mathematics, as mathematicians, we see maths as just a pattern. And so what has happened is someone back in the day found out that instead of doing all this, you can just minus the indices. Instead of doing all this, you can just add the indices, okay? So if we were told to simplify 2a times 3b, the rules apply from before. You multiply the numbers first. 2 times 3, you get 6. A times b, you get ab. Remember, you put the number first, then the letters in alphabetical order. I want you to simplify those. Be careful with these negative numbers, okay? Dave and Alicia work out the answer to 2a times 4b times 3c. Dave's answer is 24abc. Alicia's answer is cba 24. Who wrote their answer better? Remember, the question is not who wrote their answer wrong. This is still right, but they're saying who wrote the answer better. And in this case, it's Dave. But it's asking what did the other student do wrong. So this is the type of reasoning questions that you get in GCSE. You can't just say, oh yeah, Dave's answer is better, but why? Why is Dave's answer better? So you say, because when you're doing algebraic notation, you put the number first, then the letters in alphabetical order. That gives value to your reasoning. Okay, substitution is putting numbers in place of letters, basically. So when we have this, x equals to 2 and y equals to 5, all you're doing is replacing the letter with the number. So in this case, it will be 2 plus 5. This will be 2 times 5. This will be 2 times 5 over 5. And this will be 4 times 2 plus 3 times 5. Okay? Write an expression for these statements. Use n to represent the starting number. So Tom thinks of a number and subtracts 20. I'm going to write it down as this example. So he thinks of a number. We don't know what that number is, so we're going to call it n. And then it subtracts 20. So there you go. Do the other two. And then this one, Christina thinks of a number, multiplies it by 4, then adds 5. Okay, from the algebraic notations that we've just done. So she's thinking of a number, n, multiplies it by 4. So I can write 4 there. Remember, the number comes before the letter. And 4n can be written down as 4 times n. And then she adds 5, 4n plus 5. Do the other 4. And then discuss. Matti and Lisa, so this is Matti, he thinks of a number, divides it by 2, then adds 4. Lisa thinks of a number, adds 4, then divides it by 2. Will their answer be the same? If not, why not? Okay? So with these kind of questions, I usually tell my students to do this. So Matti thinks of a number, divides it by 2, then adds 4. So I have a number, I divide it by 2, and then add 4. This is for Matti. And then Lisa thinks of a number, adds 4, then divide by 2. So she's thinking of a number, she's adding 4, and then dividing it by 2. So the question is this the same as this? You can say yes or no, but that's not the full reasoning. So you need to use mathematical proof. So what I would do is I go, okay, so I have two expressions here. How can I tell whether this will give me the same answer or not? Then what about if I just use random numbers? Because I don't know what this number is. I can choose a number and see if it'll give me the same answer in both expressions. So for instance, for Matti, I could say, how about if I call this 2? So if I say, what if I imagine that Matti's number is 2, so it'll be 2 over 2, which is 1, plus 4, these give me 5. 2 plus 4, that's 6, divided by 2 is 3. So this is 5 and this is 3. Of course not. So will their answer be the same? No. Why not? Well, if we assume n is equals to 2, this is how you would answer your this question. So you'd be like, no. Because if we were to assume n equals to 2, then this expression would give us 5, and this expression will give us 3. That's my proof that they will not have the same answer. Okay? I want you to attempt these questions as well. So there's 3 questions: reasoning, and problem solving, and see how you get along. Okay, so the other subtopic is formulae. A formula is a general rule that shows a relationship between variables. For example, speed equals to distance over time, which can be written down as s equals to d over t. Speed, distance, and time are variables. Although their values can vary, the rule stays true. So this will always be the same. Speed equals to distance over time, even though the values can be different. So if we have a formula there, v equals to u plus at, and it gives the final velocity, speed in a particular direction of an object, where final velocity in meters per second, v is final velocity, u is initial velocity, a is acceleration, and t is time in seconds. So this is an example that would come mainly in the higher curriculum. So if you were to be asked to work out the final velocity of a car when u equals to 0, a equals to 2, and t equals to 11, this we go back to the earlier part of the lesson on substitution. So you're substituting the letters with the numbers. So this is the formula, v equals to u plus at. You're just putting u as 0, 2 as a, 11 as t, and then you're finding out your answer. Remember always to put your units. Okay, so I want you to try them. STEM just stands for science, technology, engineering, and mathematics. So use the formula v equals to u plus at to work out v when this is it. So this is your formula, and all you're doing is substituting these values in there to find out your velocity. This is the same again, this is a different formula, and you're substituting the values, these values, into this formula in order to get your distance. S is distance. Okay, try and do that. Expanding brackets. Expand, if you were to be asked to expand this bracket, 4 in brackets 3a plus 2, what you're trying to do is multiply this factor with all the terms inside the bracket. So in this case, it's going to be 4 times 3a, which is 12a, and 4 times 2, which is 8. I want you to expand these brackets. Be careful with these negative numbers here. There's a negative number outside. Be careful with them. And then work out the value of these expressions. Again, we're doing substitution. You see, all mathematical concepts actually interlink. You're not aware of it, but it actually all interlinks. So now we're actually doing expanding brackets, but it interlinks with substitution because we're finding the values when something is given as a number. Okay, Hannah and Benton expand 3 in brackets 2c minus 2d. Hannah's answer is 6c plus 6d. Benton's answer is 6c minus 6d. Who is correct? Again, reasoning question. Make sure your reasoning questions have value in them and you're using mathematical concepts. So in this case, if we look, we're getting 3 times 2 is 6c minus 6d. There's a minus here. So Benton's answer is correct, but of course you're not going to just say Benton's answer is correct, because if you expand this, you get that. You have to prove it. You go, okay, well, if I was to factorize this, the way I would answer it, I'll be like, with Benson's answer, if you factorize 6c minus 6d, you do get 2c minus 2d. But with Hannah's answer, if you factorize this, you end up getting 3 in brackets 2c plus 2d, which is not the same as 3 in brackets 2c minus 2d. Can you see how you've just proven to the examiner you know what you're talking about? Okay, so there's another reasoning question there. A can of oil holds 3n plus 1 liters. Write and simplify an expression for the oil in 5 cans. So this is just one can. So what do you do when you have 5 cans? You multiply them. So 5 times 3n plus 1. Basically, this just means 4. This can be written down as this way. As mathematicians, we don't like to use a lot of writing, but this is what this is. So 4 times 3a plus 2. This is basically this. And so if we have the expression 3n plus 1, we don't know what this n is, but the formula, the expression says that it's 3n plus 1. And then, so we now need to put that here and then multiply this by this and then simplify it. Simplifying means that you expand the bracket. So if we had something, I'm going to start you guys off. So 5, 3n plus 1. Be careful. Remember what I said. Whatever the factor, you need to multiply with each term in the bracket. So it's going to be 5 times 3n plus 5. And then when n is 20, again, this is substitution. When n is 20, how many liters are there in 5 cans? So expand this first. And then substitute n equals to 20. What do you get? The factors of a term are all the numbers and letters that divide exactly into it. I've just mentioned when we were talking about expanding brackets, about factors, the ones that are outside the bracket. A common factor is a factor of 2 or more terms. So if we were to be told to factorize 10y plus 25, the highest common factor of 10y and 25 is 5. So look, we have the topic of highest common factor in algebra. So 10y plus 25 is a 5. You bring the 5 outside, and then you end up with 2y plus 5 inside the brackets. You can always check your answer with algebra. The beautiful thing about algebra is you can always check your answer, whether you're expanding, whether you're substituting, whether you're factorizing. You can always check if your answer is right. So if you expand this 10y plus 25, if you get 10y plus 25, your answer must be correct. Emil and Phil factorize 8x plus 12. Emily says the answer is 2 in brackets 4x plus 6. Phil says the answer is 4 in brackets 2x plus 3. Who is correct and what mistake has the other student made? So this is a reasoning question. I want you to pause the video and try and see what reasoning explanation would you come up with, and compare it with what I will say next. So it says here highest common factor, okay? You need to find the highest common factor. So what is the highest common factor of 8 and 12? So if we try to find this out, so I have the highest common factor of 8 and 12. So if I write 8 here, I always start with factor first. I write down all the factors of my numbers, so 8 and 12. What are my factors? So it's 1 times 8. The next one would be 2 times 4, and I believe that's it. This 1 times 12. The next one would be 2 times 6 and 3 times 4. Those are my factors of 12. So I need to circle the common ones. This is my common, and this is common. This is common, and these is common. There's no other common numbers. So I've done my common, and so which one is the highest? The highest is actually 4. So Phil answer is correct because the highest common factor of 8 and 12 is 4. So you put 4 outside, and then in the brackets you try to find out what do you multiply by 4 to get 8x. So that will be your 2x plus 3. So if you were to answer this question, then you would say, well, Emily made the mistake because the highest common factor, look, I'm using the mathematical term, highest common factor of 8 and 12 is 4. Okay. Charlotte and Zir factorize 10x minus 5. Charlotte's answer is 5 in brackets 2x minus 5. Zir's answer is 5 in brackets 2x minus 1. Who is correct and what mistake has the other student made? So again, I want you to pause this video and see if you can answer this question on your own. Okay, so solve these equations. This equation, let's try and do this together as in class. So 4x minus 5 equals to 23. I always encourage my students to focus on this equal sign. So whatever you do on this side, you have to do it on the other side because of this balance. It has to balance these two because of this equal sign. It means that this is equal to this. So I'm trying to find the value of x. Whenever you're trying to solve equations, you're finding the value of x or the value of the unknown in that equation. So 4x minus 5 equals to 23. I would get rid of this 5. The only way I can do that is by adding it, because if I do minus 5 here, minus 5 minus 5 gives me minus 10. But if I do minus 5 plus 5 gives me 0. So that is how I can get rid of it. But because of this balancing method, whatever I do on this side, I have to do it on the other side. So if I'm going to add plus 5, I have to add plus 5 on the other side. So here I'm left with 4x equals to 23 plus 5 is 28. And now I'm having the same balance, but I want x on its own. When I said here minus 5 plus 5, it's because it's opposite. The opposite of negative is positive. And now here we're multiplying x times 4 or 4 times x, so we have to divide by 4 this time in order to get rid of it, because 4 divided by 4, if we had 4x over 4, this becomes just x. They cancel out. So divide by 4, x equals to 7. This is what I meant before when I said with algebra it's beautiful because you can always check your answer. So how can you check that this is the correct answer? Well, you put it back in here. So we were trying to find the value of x, right? So what if we put this x back here, the value of x here, would we get 23? So if I put 7 back here, 7 times 4 is 28, 28 minus 5 is 23. So yes, my answer is correct. So do those. Write down the lowest common multiple of 2 and 3, 6 and 8, 2, 3 and 12. When you're trying to find the LCM, all you're trying to do is the same way that I did with the highest common factor. Imagine we have LCM in an algebraic topic. That's why it's always important, whatever topic you do, you understand it because it comes up in every other mathematical concept. So LCM of 2 and 3, I would write it down as this. Again, I will start with this. So M multiple, that means I have to look at the multiplication table of 2 and 3. So 2, 4, 6, 8, 10, 12, 14, and it goes on. And then this one will be 3, 6, 9, 12, and my mind is blank, 15, 18, and 21, and you go on. And then it says the next thing you do is you find the common ones. So if I look, I have 6 here, and I have a 12 here, and then of course the others are on the other side, but I don't really care because I'm looking for the lowest, and the lowest in this case of 2 and 3 is 6. So do the same for 6 and 8, 2, 3, and 12. Always start with the multiple, find the common, and then choose the lowest. Expand and simplify this bracket. So what you're trying to do is open up the bracket. We've done it before. And then it says simplify. Simplifying means, remember when we were talking about it before, bringing the like terms together. So in this case, you don't really need to, but in this case, you would have to, because if you simplify this bracket, expand this bracket and this bracket, you would have 4 terms, and x to the power of 1 and 1 are like terms, and the other is the numbers, which are also considered as like terms. Be careful with these negative numbers. Simplify these expressions by cancelling out. I'm sure you can do it if I just do one example. So 7 goes into 14 twice, so it's 7 by 1 and 2, you end up with a 2x. To solve an equation involving fractions, multiply each term on both sides by the LCM of the denominator. So if we were to use this example, for instance, b minus 4 over 2 equals to b plus 1 over 4, what is the lowest common multiple of 2 and 4? Well, it's actually 4. Okay, so you're multiplying each time on both sides by the LCM of the denominators. So I would go times 4 on here, times 4 on there. Remember, same thing. This cancel out, but however, this one 1 and this one 2. So I end up with 2b minus 4 equals to b plus 1. Okay, expand this bracket. So 2b minus 8 equals to b plus 1. We're going back to this. Whatever you do on one side, you have to do on the other side. So I want all the b's on one side, and then I want the numbers on the other side. So if I was to do plus 8 on here, I'll end up with 2b equals to b plus 9. And then minus b here, I end up with b equals to 9. Okay, I can check. Remember, check. So if I was to check 9 minus 4, that's 5. 5 divided by 2 should give me 2.5. So b minus 4 over 2 should give me 9 minus 4 over 2, which gives me 5 over 2, which gives me 2.5. Again, on this other side, 9 plus 1 gives me 10. 10 divided by 4 is the same as 5 divided by 2, which is the same as 2.5. So yes, my answer is correct, because if this is 2.5 and this 2.5, it fulfills that equal sign. Okay, find the size of the smallest angle in the triangle. So this is beautiful. You use, again, mathematics is very beautiful, guys. You using angles in a triangle with algebra to find out the value of an angle. Can you see how the mathematical topics are all interlinked? So you need to know. So this is what we call problem solving. The examiner doesn't specifically say which topic you need to use. You need to know, tap into your mathematic knowledge and answer that with your choice of what you think you should be using. So straight away, find the smallest angle. I know, okay, angle in a triangle add up to 180. I know this sign means that it's a 90 degree. So I'll be doing 90 plus 3x plus 2 plus this thing should equal 180. Okay, that gives you your equation. And then you solve for x. It's beautiful. I'm going to leave this with you so you can solve it. Identity. First of all, I wanted to just clarify. So I've been talking about expressions and equations, but you need to be fully aware of what they mean. So an expression contains letters and numbers, but no equal sign. It doesn't have any equal sign. An equation is the opposite of this. An equation does have an equal sign. So for instance, this. So any expression without the equal sign is an expression. If it includes the equal sign, it becomes an equation. So with an equation, you're trying to solve the value of x. With an expression, you're just simplifying it. Okay, you're either expanding or factorizing. With the equation, you do those, but this time you're finding the value of x. With an identity, it just means that it's true for all values of the letters. So for instance, if we have 4x over 2, 4x over 2 can be also written as 2x, right? So that's why we use this 3 lines instead of the 2 equal signs, because this side is true. This side is the same as this side. This is the same. X in brackets x plus y can be written down as x squared plus xy. So we use the identity symbol, which is the 3 lines. A formula has an equal sign and letters to represent different quantities. So like the way we found out before, speed equals to distance over time, or area of a circle equals to pi r squared, or just come up with all the other formulas that you might be aware of. So that is a formula. The letters are variables as their values can vary. Okay? So what I want you to do is write whether each of these is an expression, an equation, identity, or a formula. Okay, you decide. What do you think is an expression, an equation, an identity, or a formula? I know straight away this is a formula. E equals to mc squared. If you don't know it, just look into your notes. I'm assuming this will be in the physics curriculum, so try and look at that. But this is E equals to mc squared is a formula. And what about writing down your own examples of an expression, an equation, identity, and a formula? And beside each one, write how you know what it is, okay? Okay, this is a higher curriculum topic, linear sequence. In an arithmetic sequence, the terms increase or decrease by a fixed number called the common difference. The nth term of an arithmetic sequence is common difference times n plus 0 term. So this is a formula now. So the nth term of an arithmetic sequence equals to common difference times n. This common difference just means the number that's going up or down times n plus 0 term. So if we were to look at this example, work out the nth term of the sequence 3, 7, 11, 15. So the first thing we need to do is find the common difference. Okay, so the common difference in this case, well, it's already done here. So it's plus 4, plus 4, plus 4, plus 4. So that is your common difference. So straight away you write your 4n, because 4 times n, as we found out earlier on, can be written down as 4n. And then it says plus 0 term. What I usually say, so 0 term means this is your n1. So this is n equals to, if we write n here, this is 1, 2, 3, 4. So this is your first term, second term, third term, fourth term. What they're saying with 0 term is that if you were to put 0 here, what would be your term? Well, it has to be a number where if you add plus 4, it should give you 3, which is -1, because -1 plus 4 gives you 3. So this is your 0 term. But I teach it differently. I just say, well, okay, so you know the difference is 4, and then you know times n, it's 4n. What do you have to do to 4n to get to 3, right? 4n plus what or minus what gives you 3. We assuming, when I say that, I'm assuming n is 1, because right, with 3, n is 1. So if I was to substitute and put 4 times 1, I get 4, right? So 4 plus or minus what gives me 3? Well, in this case, it's minus. So my answer would be 4n minus 1. Without having to work out what the term is, the 0 term, I straight away know from the first term. Okay, and then it says, is 45 a term of the sequence? So we're trying to check now, yeah? This is called mathematical proof. You're trying to see, using the formula, if 45 is a term in the sequence. So you do 45 equals to 4n minus 1. Again, look, this is linear sequence, but we're trying to solve an equation here. So plus 1, you get 46 equals to 4n. Divide by 4, you get n equals to 11.5. Well, 45 cannot be in the sequence because 11.5 is not an integer. Look, n has to be a number, 1, 2, 3, 4, 5. You can't have 11.5. It's either going to be 11 and then 12, and then, you know, it goes on like that. But can you see how beautifully they explained it? They said, because 11.5 is not an integer, using mathematical terms to explain your answer. Okay, write down in terms of n expressions for the nth term of these arithmetic sequences. So if I was to do this, so I know it's going up by 2. So it's plus 2, plus 2, plus 2, plus 2. So it'll be 2n for me. And then what do I need to do to 2n to get to 3? Plus 1. And that is my expression. So try and do the rest. And then answer this question. Look, it's a 3-mark exam style question. Here are the first 5 terms of an arithmetic sequence. Be confident with this. Arithmetic means that it's going up with a common difference. So arithmetic sequence 3, 9, 15, 21, 27. Find an expression in terms of n for the nth term of this sequence. So you know, you find the common difference, you multiply by n, and then you find out how to get to this 3. And then Ben says that 150 is in the sequence. Is Ben right? Explain your answer. Even though it's 1 mark, please do not underestimate this, because there's so many reasoning questions in the exam. So all these 1 marks build up. So it says, we've just done it, right? So if we're trying to find whatever your value is here, your nth term formula, then you're equaling it to 150, solving it using your knowledge of solving linear equations that we've just done, and then say whether Ben is right or wrong using mathematical terms. Okay, if it's not a whole number, then you'd be like, sorry, it can't be a term because n cannot be a decimal place. It has to be, it can't be a decimal number. It has to be a whole it has to be an integer. Okay, we're going to look at 2 non-linear sequences. The first one is a geometric sequence where the term increases or decreases by a constant multiplier. So you're multiplying by the same number in each term. Before it was adding and subtracting, this is multiplying or dividing by the same number. So write down the first 4 terms of each sequence. If I was to do this example with you, so the first term, second, third, and fourth, this would be 1 over 1, which is 1. This is 1 over 2, 1 over 3, 1 over 4. Okay? And then it says which of these are geometric sequences. So check them. If you were to write this down, is there a constant multiplier? If there isn't, then no, it's not a geometric sequence. If there is, then yeah, it is a geometric sequence. A quadratic sequence has n squared and no higher power of n in its nth term. I'll explain this using an example. So when you have a quadratic sequence, you can't have anything more than n to the power of n squared. So you need, if you had n cubed, then that's not a quadratic sequence. A quadratic sequence is n squared. So if I was to be given this example, copy and complete to work out first and second differences for the sequence n squared plus 1, this is what you would do. So you would find out the first difference. Remember, with the arithmetic example, the first difference was the common one because it had the same common difference. But in the quadratic sequence, you have to do two differences. So the first one will be 8 plus 3 is 11, 11 plus 5 is 16, plus 7 is 23, 23 plus what? It gives you 32. And then once you do that, basically you're doing 32 minus 23 to get your answer. And then in here, you're trying to find whether there is a common difference. If there is a common difference, then yes, this is a quadratic sequence. So this is 3 plus 2. So between 3 and 5 is plus 2. 5 and 7 is a plus 2. So this plus has to be plus 2. And this is 9 because 32 minus 23 is 9. Okay, so this fulfills this sequence. Okay, do the same for here. So basically what you're doing is, okay, you have the sequence here. How they found this? Do you know how they found this 8, 11, 16, 23, 32? Because this is just the sequence. How did they know that it's going to be 8, 11, 16, 23, 32? Well, this is what they did. They substituted n 1, 2, 3, 4, 5 because this is, if we were to look at this, this is the first term, second term, third term, fourth term, and fifth term. If n equals to 1, so it will be 1 squared plus 7, which is 8. If n equals to 2, 2 squared, which is 4, plus 7 is 11, yes. 3 squared, 9 plus 7 is 16, yes. 4 squared, 16 plus 7 is 23, yes. And then 5 squared, 25 plus 7 is 32. So that's how they got this number. And they found the difference, and then they found the second difference. Okay. Okay, continuing with nonlinear sequences, the second difference of a quadratic sequence where we have this, which is un is equals to an squared plus bn plus c. This is a general formula. They are constant and equal to 2a. So this is the second difference. Let me give you an example. So what if previous example we were already given the formula, this formula. But in this example, we were just given the sequence and we need to find this formula. What is the formula? Okay, so I have 8, 23, 48, 83, 128, which is what I have here. I first find the difference. So what's the difference between 8 and 23? It's plus 15. This and this, 23 and 48 is plus 25. 48 and 83 plus 35. 83, 128 plus 45. And then now I need to find the second difference. And then I have here, which is plus 10, plus 10, plus 10. So I know this is going to be a quadratic sequence because the second difference is constant. Okay, what we're saying is that this second difference, this statement is saying is that this second difference is 2a. To find this a value, we need to divide that by 2 because 10a is 2a. Okay, basically what they're saying, this 2a is 10. So what would a be? A would be 5. So formula, this becomes 5n squared. So the formula has a 5n squared. We know straight away the first term would be 5n squared. So in order to find out this and this, we look at it, we go, okay, if we were to have 5n squared, what would that sequence look like? Well, 5n squared is, if we were to put 1 here, it becomes 5. If we were to put 2 here, it becomes 2 squared, which is 4 times 5, 20. If we were to put 3 times 3 squared is 9 times 5 is 45, and you go on. But however, the sequence that we have, so this is the sequence for 5n squared. But we have a different sequence. We have 8, 23, 48, 83, 128. So what is the difference between the two? as you can see, you're adding plus 3. So you've added 5 plus 3, 20 plus 3, 45 plus 3. So basically the sequence has been shifted plus 3. So your formula for this sequence becomes 5n squared plus 3. Okay, so thank you so much for joining me, and I will see you in next lesson.